So we are starting a new session on Python. So introduction to Python, chapter 1, domain name will be Python programming. So what is the agenda here? So what can we do with Python? See, Python is a programming language which is quite famous right now, and it can be applied in different domains. For example, we can use Python for web development. We can use Python for machine learning. We can do Python for even general programming, general purpose programming. So Python can be used for various purposes, right? And Python is quite easy to learn, and it's fully object-oriented language. So all the concepts which are applied here in Python are object-based. So Python is quite good language, and also it has got wide support from the various communities. So you can solve any problem using Python, using some community, Python community, right? So when you talk about Python, we start doing Python program using one of the editors. Actually, we can use PyCharm or Anaconda Navigator. So in this session, we'll be using Anaconda Navigator as our editor, through which we can create Python scripts with an extension .py. Okay, and when we talk about Python, we should know what is indentation. When you say indentation, how do you group block of statements, so that they come under the same division actually. So the distance of each statement to the right end, that's called a block. For example, you see all these statements. If you look at this diagram, block 1, block 2, block 3. See, block 1 contains block 2, block 2 contains block 3, and all the statements in block 3, they start here and go up to here. Okay, so they end here actually. So that's called the distance of each statement to the right end. Okay, that should be same. Okay, for block 3. For example, block 2, if you take the statement, they start here and end here. And of course, all the statements will start at the same point. Look at this. Okay, that's called indentation. Actually, see, compared to other languages, here the indentation is a compulsory one. In other languages, indentation is an optional one, but it's a language requirement. Okay, Python language requirement. So if the indentation is not proper, then the compiler will not compile the program. Okay, so the same way you see block 1 statements, they start here and they go up to here. So that's called block 1, block 2, block 3. So indentation is nothing but every statement's distance, from that particular point to the end of the right end. That's called indentation. Okay, I think probably I'll just show you demonstration, a lot of demonstrations. And when we talk about Python, we should know what is a variable, data types. Okay, of course, when you say data types, compared to conventional programming languages like C, C++, or Java, we do not need to declare the data types of variables. Okay, so there is no specific data type called explicit. There is no explicit data type called integer, float, string, char. Okay, there is no explicit data types here in Python. In fact, you don't need to explicitly declare any data type in Python. Fine, everything is implicit actually. See, the moment you think about a variable, you start using it by assigning a value. That's it. Okay, the value which you assign, that type is given to that particular variable. That's all. Okay, so variable is nothing but a container actually. Okay, but again here it differs actually. See, in conventional programming languages, we have a pigeonhole concept where the value goes and sits inside a variable, like a shoebox. See, inside a shoebox, we put shoes. That's kind of a pigeonhole. We call pigeonhole. But in Python, it is not pigeonhole concept actually. See, the objects are created. Basically, Python is a fully object-oriented language. So everything is an object of a particular type. For example, if you take 25 as a value, it is an object of integer, number basically. If you take 25.5, then again it is an object of float type. Okay, now when you say variable, it holds the address of the object. So it refers to that particular object. So we don't store values inside a variable. Okay. See, the conventional programming languages, we store values directly inside a variable. But in Python, we never store, okay, the values inside a variable. The values, the variables always refer to the objects. Okay, fine. So that is the reason we don't need to have any data type, because see, when it's only a reference, the variable can refer to any data type. Okay, for example, if you take x as a variable, okay, x may initially refer to an integer. Next moment, the x can refer to a floating point number 25.5. The very next moment, the same x variable can refer to one string object. So you see here, we cannot fix a data type. Okay, so that is the reason there should be no data type declaration in Python. Okay, fine. So it's called dynamic data type. So depending on the value which you store inside a variable, the type is assigned. The type is assigned. Okay, that's called dynamic data type. Now you can see how do you create. Okay, see every variable. Okay, now let us see. We'll be discussing about identity function. That's called ID of a particular variable or object. See, every variable or object will have an identification ID, like SSN number in social security number or Aadhaar card in India. Okay, so every object will have a unique number. Okay, and of course, we will be discussing more on practical example. I think let me get into Anaconda Navigator. So you can see here, I have opened already an Anaconda Navigator. You can see an Anaconda Navigator, inside which I start Jupyter Notebook as my editor. So I launched here already. So it got launched here. Look at this. It got launched here. So you can I'll just stop, close the other windows. So you can see here. Okay. I'll close everything. Okay. So you can see, in fact, it starts like this. Oh, sorry. It will be Anaconda Navigator. I will start, the navigator here. Launch. So I started Anaconda Navigator. Then I clicked on launch button of Jupyter Notebook. So it's launching now. It takes some time, that's all. So it should be open now. Okay, just we'll wait. Yeah, you can just. So it may ask for a password. I'll just give my password. Okay. Sometimes it asks for password. Yeah, look at this. Now this is the area where we are landing on. Okay, so I just click here. Look at this. I clicked on that slash. So I can select any of the folders which I already created. Let me take one folder called documents. Okay, so I am into documents folder. Okay, you can create any folder already. If you have created, you can create any folder. Okay, now what I can do, I am inside documents. So I'll just say new Python 3. Python 3. You can see it. Yeah. Now this is our Jupyter Notebook editor screen actually. So here everything will be a cell. See, look at this is a cell. Okay, I can add more skull, escape B. Okay, so a cell will be added at the end, appended at the end. So I want a cell above it. So I'll just say escape A. So a cell will be added before. So you can keep adding cells. See, the advantage of having a cell structure in Anaconda, in Jupyter Notebook is, see, you can execute only this particular cell. You don't need to execute the complete program. See, you may split your the complete coding into different parts, sections. Okay, but you can just execute on this section. See, for example, this is called section 1, section 2, section 3. Let me just add something. For example, I'll just say first let me take a variable. Variable naming convention is quite very well known actually. Every variable should start with a capital letter or small letter. Okay, or it can start with an underscore. Okay, it can contain numerical digits. Okay, but it cannot start with numerical digits. So for example, I can just say, okay, for example, principal. Let me take a simple example. Area of circle. So I can just say circle area underscore circle. Okay, like that I can declare a variable. Okay, fine. So I can just say radius. radius is equal to, so I can just give a radius value, I can just give 10, fine, is radius equal to 10, I have given. Now what I'll do, I want to print it, I can either say print radius, or I can simply say, you can see 10 got printed, okay. So or I can say print radius, it doesn't matter, both are same. So you can see here print radius. Now what I can do, okay, here I will just go, now type of this, what is the type of radius, I'll just say type of radius. So you can just see class int. So as I told you, in Python everything is an object. So 10 basically it is an object of class called int. So this is the class name. Int is the class name. Okay, 10 is your object, int is the class name. Right? Okay, then I can have, okay, I can do something like this. See what I'll do, I'll just say temp is equal to radius. Okay, now look at this. I will just say temp. Okay, look at this. Now what happens is both radius and temp, they refer to the same 10 object. Okay, 10 is an object, integer object. Here both radius and temp refer to the 10 object. Okay, how do you prove it? For proving it only, what we are going to do, we are going to use id of temp, comma id of radius. Look at this. Now see, temp variable and the radius variable, they have both, okay, common id, that means 208, 6208 or 6208. That means they refer to a single object called 10. So id function gives you the identification number, unique identification number of every object or variable. Okay, here we have two variables, temp and radius, both refer to the common object called 10. Okay, so you can see here both are same number. Now how do I differentiate? Now what I'll do, I'll just say, to prove it, I'll just say temp, okay, is equal to, I'll just say okay, 100. Okay, now look at this. So 10 is a different object, 100 is a different object. Okay, or if I just say, before I do that, now I'll just say comment is hash is for comment. Okay, now I'll just remove this also. Okay, so see, both radius and temp, they refer to 10. Now if you look at this carefully, now I'll just again run the id. Now we are not, making, okay, temp to refer to the same object as radius. Okay, now I tried to put 10 inside radius and 10 inside temp. Now let us see what happens. See, again the IDs are same. As long as the object value is same, see, the same object is referred by any number of variables. Here we see radius refers to 10, same 10. You can just say it is centrally located. And temp also refers to the same 10, even though it likes, trying to assign a different value, different kind of value. Both temp and radius, they refer to single temp 10 object. Right? Now how do I differentiate? Now what I'll do, I'll make it 100. Now look at, I'll just control enter for running. See, any cell if you want to run, just control enter. Okay, now you can see, look at this. Temp got different ID and radius got different radius. Radius remains as 6208, but temp refers to 7568. Now you see, as the object changes, okay, the variable which refer to that object, they get a new ID. See, previously it was, see, now radius refers to 10. So 10's ID is 6208. Now 100's ID is 7568. Ending with 7568. Okay. So what happens is, now there are two different objects. So in Python, you can differentiate, okay, two different objects or two different variables by, okay, invoking the identity function, ID of that particular variable or object. So that will give you the unique identification of every object. Okay, so hope this session was useful. We'll continue in the next session. Thank you.